Welcome to our lesson. I'm Mrs. Gradney, and today we'll be expressing metric mass measurements in terms of a smaller unit, and we'll be solving addition and subtraction problems involving mixed units. Let's get started. This water bottle weighs 1 kilogram. We can also say it has a mass of 1 kilogram. Everyone whisper mass. So let's prove it. Here I have a balance scale. On a balance scale, we can measure the weight or mass of objects by putting a weight on one side and an object on the other side, and if they balance, then we know the mass of that object. Right now we can see that the scale is balanced. The needle is pointing straight down. Now here, I have a 1 kilogram weight. If I put this 1 kilogram weight on one side of the scale, we can see this side go down, so it puts the scale off balance. So let's measure the mass of this water bottle. I'll leave the 1 kilogram weight on this side, and I'll put the water bottle on this side. And we can see with the water bottle on one side and the 1 kilogram weight on the other side, they balance. So we can say that the water bottle has a mass of 1 kilogram. Here, I have a dollar bill. Imagine holding a dollar bill. It's pretty light, right? A dollar bill has a mass of about 1 gram. So think about this paper clip. Would this paper clip have a mass of about 1 gram or 1 kilogram? What do you think? I'm thinking it's closer to 1 gram because it's also really light, like a dollar bill. So let's try it out. Right now we can see that the scale is balanced. Here I have a 1 gram weight. I'll put the 1 gram weight on one side, and we can see that side go down a little bit, right? I'll put the paper clip on the other side, and now we can see that the scale is balanced. So the paper clip has a mass of about 1 gram. So now I want you to think back to something that you learned in 3rd grade. How many grams are equal to 1 kilogram? Let's read this equation on the screen. 1 kilogram equals 1,000 grams. So then, how many paper clips like this would it take to equal 1 kilogram? What do you think? Well, if 1 paper clip equals 1 gram, and it takes 1,000 grams to equal 1 kilogram, then 1,000 paper clips should be equal to 1 kilogram. Let's try it. Here I have our 1 kilogram weight. I'll place it on one side of the balance scale. And here I have a bag of 1,000 paper clips that I'll place on the other side of the scale. And we can see that they balance. So 1,000 paper clips, which is about 1,000 grams, equals 1 kilogram. Let's put this knowledge to use. Let's use a chart now to show the relationship between kilograms and grams. We already know that 1 kilogram equals 1,000 grams. So how many grams are equal to 2 kilograms? 2,000 grams. How many kilograms are equal to 3,000 grams? 3 kilograms. How many grams are equal to 4 kilograms? 4,000 grams. Pause the video now and complete the chart. When you're finished, come back, compare your work with mine, and check how you did. Here's the completed chart. How'd you do? Now, let's use what we know about how many grams equal 1 kilogram to rename or convert to smaller units. Take a look at this. Read this with me. 1 kilogram, 500 grams. Let's convert 1 kilogram, 500 grams to grams. How can we use what we know to help us? Pause the video to talk out your thinking. You may realize that we already know 1 kilogram equals 1,000 grams. So we can think 1,000 grams plus 500 grams equals 1,500 grams. So 1 kilogram, 500 grams equals 1,500 grams. What about this one? Let's read it together. 5 kilograms, 30 grams equals how many grams? Pause the video if you need to have time to convert, and then come back and we'll talk about it. Some of you may have said 5 kilograms, 30 grams equals 530 grams. But why isn't 5 kilograms, 30 grams equal to 530 grams? Well, if we know 1 kilogram equals 1,000 grams, then 5 kilograms equals 5,000 grams. 5,000 plus 30 equals 5,030, not 530. So 5 kilograms, 30 grams equals 5,030 grams. Let's switch it up a little bit. Read this equation with me. 2,500 grams equals how many kilograms? How might we figure that out? Pause the video to talk out your thinking. One way we could think about it is that 2,500 grams could be decomposed into 2,000 grams and 500 grams. These 2,000 grams are equal to 2 kilograms, and then we still have these 500 grams. So 2,500 grams equals 2 kilograms, 500 grams. Let's read this expression out loud. 8 kilograms plus 8,200 grams. How can we use what we know to help us solve this problem? Pause the video and talk out your thinking. You probably noticed that the addends in this expression have different units. The first addend is expressed in kilograms, and the second addend is expressed in grams. We can't add together the different units, but there is more than one way to think about solving this problem. One way to think about it is we could rename the kilograms to grams. So 8 kilograms converted to grams would be 8,000 grams. And then we could add that with the 8,200 grams. Now we have like units and we can add. Or you may have thought we could convert 8,200 grams to kilograms. 8,200 grams converted to kilograms would be 8 kilograms, 200 grams. Then we would add that with the 8 kilograms. Now, would you choose this problem using an addition algorithm or a simplifying strategy? Remember, a simplifying strategy is one that helps us to do mental math. I was thinking this would be a great problem to use a simplifying strategy because the numbers can be added mentally. In this example, 8 kilograms plus 8 kilograms is 16 kilograms, and then we would just add on the 200 grams. So it would be 16 kilograms, 200 grams. If I chose to convert the kilograms to grams, I could think about this in unit form, and 8 thousandths plus 8 thousandths is 16 thousandths, just like we did here with the kilograms, and then I'd add on the 200s. So it would be 16,200 grams. So we we can say 8 kilograms plus 8,200 grams equals 16 kilograms, 200 grams, or we could express it as 16,200 grams. Either way is correct. Let's try another one. Let's read the expression together. 25 kilograms, 537 grams, plus 5 kilograms, 723 grams. How would you solve this problem? With an addition algorithm or a simplifying strategy? Pause the video and explain what you're thinking. Now, choose the way that you want to solve the problem, and pause the video again and solve it. When you're done, come back and we'll compare solution pathways. Hopefully you found that the sum is 31 kilograms, 260 grams. Or you may have added in grams and got 31,260 grams, which is also correct. Here are 4 different ways that you may have solved the problem, though these don't represent the only ways you could have solved. Do any of them look similar to how you thought about it? Pause the video and analyze each of these solution pathways. See if you can explain out loud how the problem was solved in each solution. In solution A, an algorithm was used, but they added together the kilograms with the kilograms and the grams with the grams. Why is this number bond shown here? This number bond shows how 1,260 grams was renamed into 1 kilogram, 260 grams, which gave a total of 31 kilograms, 260 grams. In solution B, another algorithm was used. But what's different from solution A? In this algorithm, the mixed units of kilograms and grams were first renamed as grams before adding. Solutions C and D used simplifying strategies. In solution C, the kilograms were added together first, then the grams. When adding the grams, what does this number bond show us about the thinking? The number bond shows us that they made the next 10. 7 from 537 put with 723 makes 730. 530 plus 730 is friendlier to add mentally than 537 plus 723. Here's another one. Let's read the problem together. 10 kilograms minus 2 kilograms, 250 grams. First thing, would you use a subtraction algorithm or a simplifying strategy? Now, choose the way you want to solve and pause the video and solve it. If you want to challenge yourself, try to solve the problem in more than one way. Then come back and we'll compare solution pathways. Welcome back. Hopefully you found the difference was 7 kilograms, 750 grams, or 7,750 grams. Here are 4 different ways you may have solved. Though these aren't the only correct ways you could have solved. Do any of these ways look similar to how you thought about it? Pause the video now to analyze these different solution strategies and explain out loud how the problem was solved in each of these ways. Solutions A and B use an algorithm. In solution A, where did these 1,000 grams come from? We can see they decomposed or unbundled 1 kilogram as 1,000 grams so they could subtract 250 grams. How is this similar to what happened in solution C? In solution C, 2 kilograms was subtracted from 10 kilograms first. So then the problem was 8 kilograms minus 250 grams. In order to subtract the 250 grams, they decomposed 8 kilograms into 7 kilograms and 1,000 grams, just like how the 10 kilograms was decomposed into 9 kilograms and 1,000 grams here. Excellent work today, friends. I think we're ready for our problem set. On the screen are the must-do problems for this problem set. Set a timer or watch the clock for 10 minutes to work on these problems. If you have any extra time, feel free to work on any of the other problems as well. Today, we expressed metric mass measurements in terms of a smaller unit, and we solved addition and subtraction problems. Remember to check in with your teacher, and I'll see you next time for another Eureka Math lesson.